Hello, my name is Robin Mitchell, and welcome to this podcast for Electropages. In today's podcast, I'm joined by Stefania Sesia.
Yes, absolutely.
Got it right. And you're from u-blox.
Absolutely.
And today we're going to be looking at some rather interesting solutions that you've brought out to give us, and I think you said it was Decimetre Precision.
Yes, so today what we are announcing is a new solution that provides integrity and safety and brings integrity and safety into the autonomous world, basically in the automotive market. So this is a new announcement that we had just this morning about our new product related to safety and integrity.
So could you just give us a bit of a dive into what it's actually doing and how it's able to achieve its ability to have decimeter resolution?
Absolutely. So first of all, maybe we can start with why it is important to have this, right? I think that we are facing a revolution nowadays because of the autonomous vehicle. We are used to have humans behind the wheel that are capable of dealing with uncertainties, very difficult conditions, complicated roads. And today we are shifting the responsibility to the vehicle. So the vehicle, especially with the AD level 3 up to the AD level 5, needs to be capable of handling those very complicated type of scenarios. And here the key word is really safety and trustworthy for the data that are used in order for the vehicle to take decisions. What we believe is that for the positioning system, in order to make sure that the vehicle can localize itself in a safe manner, we need to provide a positioning solution that is also providing safety and integrity, and on top of that, high accuracy, high precision type of solutions. So as u-blox, we have a vision that the next generation of positioning needs to be safe, with high integrity and with high precision.
I'd like to just pick up on a word that a phrase that you said about a minute ago, and I've never heard it before, and I really like it. You said about shifting responsibility to the car and taking it away from the driver, and I never ever heard anyone say it in those words. So that's quite an interesting thought, actually, to incorporate electronic systems that essentially say, let's be honest, humans are stupid. They don't always watch what they're doing. They don't look at the road. They don't listen to what's going on around them. And so the car has to take responsibility. Now, what challenges is it that... So basically, what is the biggest challenge that GPS faces at the moment? Why can't you use it for these applications?
So, first of all, I'm not saying that humans are stupid, of course, but...
They are.
But when you move from an autonomous driving level 2 to an autonomous driving level 3, here is where there is the shift in terms of responsibility. Up to AD level 2, the driver can remove his remove his hands from the wheel, so they can be there. They can remove their hands from the wheel, but they still need to be conscious about what is happening. But then when we move to AD level 3, then the SAE system says basically that you have the possibility as a driver to remove your hands from the wheels and remove your eyes from the environment, which means that basically, at least at the beginning, from a portion of the streets, from a certain time, the vehicle itself can take the control and they can take the decision about basically the maneuver that it has to do. So of course, this poses quite some challenges because you need to be capable of handling different scenarios, different conditions, different road topologies, and so on. One of the first function that the vehicle has to do is really localize itself into the environment. And here the GNSS can provide an extra layer of safety together with other sensors like a camera, radar, LiDAR. And since the GNSS is the only sensor that provides absolute positioning, but is also having different characteristics compared to camera, radar, LiDAR, it can also offer an expansion of what is called the operational design domain, which means basically extending the availability of the functionality to a larger set of scenarios. So basically what we see is that the GNSS offers an additional layer in terms of safety when we associate the safety requirements to the GNSS and an additional information that can be used in order to extend the functionality, the availability of the functionality for the localization.
Now, GPS itself cannot provide a decimeter the ability to know where you are in the decimeters. It's more of like the meters.
Yes.
Are you saying that you combine GPS with other solutions to basically shrink that size down?
Absolutely. So first of all, there are two things. First of all, in order to achieve decimeter level of accuracy, you need to have diversity. What it means is that you need to use different frequencies in order to have more diversity.
Yeah.
For example, L1, L2, L1, L5, and on top of that, you use multi-constellation type of approach. So in u-blox, we have a roadmap of solutions that spans from standard type of precision, meter level accuracy with a single band type of solution to until decimeter level of solutions that use multi-constellation, multi-frequency type of solutions. And on top of that, when you want to reach a very high level of accuracy, you need also to have what is called a correction service. A correction service is a cloud-based type of service that basically relies on a network of ground stations that help you correcting the errors that comes from the fact that the signal passes through, for example, atmospheric impairments, like, for example, ionosphere, troposphere, and so on. Those correction services are delivered to the onboard, the system on board, the sensor fusion, and these algorithms, there are those algorithms that are capable basically of achieving then, thanks to those correction service, decimeter level accuracy. In the context of autonomous driving, it is not only high accuracy that is important, but it's also integrity and safety. What it means is that, first of all, you need to be capable to guarantee that your system is free of errors that comes from malfunctions because of the hardware and the software. But on top of that, your system is capable of dealing with environmental impairments coming from, for example, the fact that you have multipath, you have buildings, you have trees. So you need to be capable of guaranteeing where your true position can be with very high probability. So this brings us to a concept of integrity. That is exactly what we announced today with u-safe. That is our new positioning solution that guarantees a safety and high integrity solution through a concept that is based on what is called the protection level. The protection level is a bounding box around the vehicle in 3 dimensions that basically tells you where your true position is located with extremely high probability. So you want to guarantee that you can have an outage with very low probability, like, for example, once every millions of hours of drive. So this is very important because you guarantee that your true position is located within this bounding box around the vehicle. And this is exactly what we are showing here with this EVK today in order to show the concept of integrity and what we have announced today with u-safe.
So the product, the product that you've released, and you're saying you've got an evaluation kit here. Is it a chip or is it a module or is it a?
Yeah. So our u-safe solution is basically created out of 3 components.
Right.
We have the hardware component
Yep.
that actually you can see it here. Actually, you don't see it. It's very small.
You got black PCB with a black chip.
Yes.
It's that one right there in the middle.
Yes,
Yeah,
there is
Yeah.
one chip. Actually, we need 2 chips in this case to support the 2 different bands. We have chipset or module type of solution. The hardware is our 9th generation of platform. It's called the A9. This hardware is already already used in a running fleet with an OEM. So it's a solution that has been already proven into the market. And now we are enhancing this solution already through the 2nd generation of improvement, basically. But this is a proven technology, validated already into the market. We are combining the hardware solution. First of all, the hardware solution, the A9, is developed according to the ISO 26262 standard, the functional safety standard, with a rating that is ASIL B. We are combining these with a second component that is called the point safe. Point safe is a combination of the position engine that is filter software, basically, host-based, that is capable of fusing the information that comes from the A9, so from the receiver that receives all the data from the satellite, combining these with data from the inertial measurement unit or the wheel tick.
I was literally about to ask you about that because the u-blox solution that you've got here, and it's able to very accurately position where it is. I was going to say, is it purely through constellations, or is it also using like an onboard IMU to figure out, so for like dead reckoning,
yes.
so it knows quite where it is?
Yeah, so the positioning engine, as I was mentioned, is a fusion algorithm that takes into account the information that comes from the GNSS, so the measurements that comes from the GNSS receivers. It uses the information from the inertial measurement units, the information from the wheel tick as well, and wheel tick. This is the interface basically that comes from the wheel tick. It's how the wheels are moving basically.
Really?
This is used specifically for the dead reckoning type of algorithm.
So it's really it's not just like a radio module stuck into the car that tells you some numbers. It really is integrated with the car's electronic system.
In the particular demo that we have shown today, we didn't have the integration with the wheel tick, but in the actual car, yes, of course, yes. You have the integration with the wheel tick of the vehicle. But then what is important is that with this position engine that is tucked into this host, we are also taking into account the correction service, a safe correction service that is delivered through the internet, through the IP data. In this EVK, it is delivered through this interface, C data, so correction service data. The correction information comes into and is understood by the position engine, and the position engine as such is capable of guaranteeing certain performance in terms of protection level, certain performance in terms of accuracy, and in particular very high integrity up to 10 to the minus 6, 10 to the minus 7, thanks to the use of the complete set of components in order to create the integrity concept.
That's really interesting. Now, one question I actually do have about this system. If I remember, this one doesn't work with cameras and LiDAR and radar, does it, at this point? But would future versions use that kind of information as well, do you think?
So, in principle, in the car, the car OEM, in order to localize the vehicle, it's already using the camera, the radar, the LiDAR. This is a particular solution that provides an absolute position as output, and this can be used then in different use cases. The absolute positioning solution can be used, for example, for geofencing, in order to decide whether or not for that particular portion of the street you want to activate maybe a specific function. It might be used for the localization, as an input for the localization function, together with camera, radar, LiDAR. And it can be also used as an input for navigation, for example, or for V2X vehicle to everything type of technology, which we believe that in the second generation, for new use cases, there will be the need to have also high integrity.
And so, just to be clear, it's like a three-part solution. You've got the chip itself, you've got the software for it, and I believe there was a module as well.
So the hardware side, in this case, we have chipset, but the hardware side comes either in a chip format or in a module format, depending on the different customers. The software and the correction service is a cloud-based type of correction service that is based on a certain set of ground stations.
And I take it, does the chip itself have the ability to use mobile networks, or is that something you use a secondary u-blox solution for?
Sorry, can you clarify the question? The chipset is using a cellular network.
So, because you said you've got the cloud-based service,
yes.
So you need to connect to that.
Yes.
And so so the chip here needs to connect to that via an additional module?
No, so the chipset doesn't require the need for correction service. It is the positioning engine that is hosted here that requires the need for IMU information, for the correction service information. So typically the correction service comes from the IP network, so an LTE 5G network through a telematics system in a real integration into the vehicle, and it is delivered to the host that hosts the the position engine in order to be exploited and to have then the complete integrity concept. Maybe what I would like to mention also is that this comes after the partnership announcement that we did in March with GMV. That is a Spanish company that is leader in positioning in civil aviation and is translating now this safety experience also in the automotive market. So we are together putting in the market this new U-Safe solution. u-blox commercialized this solution, and the strength of this solution is that we have a pre-integration with the different components, pre-validation, pre-certification, so that basically this reduces the effort from our customers, because we simply, first of all, simplify the supply chain, but also the effort in order to reach validation, certification, and so on.
So just before we wrap this interview up, I have one last question. For engineers watching this video right now, if they want to get started with this new solution, what would you recommend they do?
So they need to get in touch with u-blox. We are the one providing the entire end-to-end solution. And what needs to be very well understood is really how the customer wants to use the information, what are the use case, what is the context. We deliver the solution as a safety element out of context, which means that basically we analyze, we pre-certify the solution by taking some hypotheses independently from the system that will use the solution, but of course the solution then has to be integrated into a vehicle. So we need to understand what is the context of our customers, and we need to make sure that we provide the right level of support for the integration and the final certification for our customers. So the best thing is to get in touch with us, and we can start very happily a discussion about what are the use case, what is the architecture where they want to integrate, so that we can support them with the right level.
Fantastic. Well, thank you ever so much for taking the time to see us today.
Thank you very much.
Thank you.